Question number 18. Two identical wires X and Y are connected with the switch to a cell of negligible internal resistance as shown. Okay. Electrons in Y have a drift speed of Y V when the switch is open. When the switch is open, all the current will flow like this. Okay, so let us write down the equation for this. I is equal to NEAVD. So here let me write Vy over here. Okay, so therefore next, when the switch is closed, what is the drift speed of electrons in X? When the switch is closed, now what will happen? The current I here will not be the same, current will be more, right? So which will now be equal to, if E is the EMF of the cell, I can now write E divided by, if both of them are the same identical wires, if this has a resistance R, this will also have a resistance R. Okay, so therefore effective resistance of this would be R by 2. How do I know R by 2? The reason is because 1 by Rp is equal to 1 by R plus 1 by R. So this should be equal to 2 by R. So Rp should be equal to R by 2, right? Thus a new current I dash will be equal to E divided by R by 2, which should now be equal to 2E by R. Okay. Now what was the old current when this was open? The old current was I is equal to E divided by R. Now you see what is the relationship connecting I and I dash here? You can see I dash should be equal to 2 times I, right? So therefore when this is closed, a current, new current 2I will enter here. When it comes to this node, what will happen? It will split into two currents, I and I here, so that I plus I equal to 2I by Kirchhoff's current law, right? So therefore here also same current flows. So if the same current flows, then what is the drift velocity here? It will be the same as what was observed for the current I, right? So therefore Vx will also be equal to Vy over here. Thus the answer here is B, because Vy is equal to V, Vx is also equal to V. Okay.